I want to go ahead and welcome everybody to today's webinar with ATG. I appreciate you tuning in today to learn about harnessing the power of Subassembly Composer. This is a tool that will definitely make building subassemblies to your specifications not only easier, but also unlock your creativity on what you can do with a corridor and subassemblies. If you want to stay up to date on all of the latest webinars that ATG puts out, you can join our LinkedIn page to stay in the loop. If you want to rewatch this webinar or see other webinars that you may have missed, go ahead and check our YouTube page, youtube.com/C/ATG USA. My name is Felix Cortez. I'll be doing your webinar today. I'm a civil infrastructure technical specialist and Autodesk certified instructor here at ATG. We're a platinum partner with Autodesk and Bluebeam, and our goal is to be your one-stop shop for not only your licensing, but also training and support. We have hardware solutions in the form of BIMbox if you're in need of new computers that are specifically designed for the AEC suite. I know I personally love doing these webinars and creating content to help our customers not only be more efficient, but also proficient in the software that they use every day. So what are we going to be going over today? We're going to be going over the Subassembly Composer interface. Not only with the interface, there's also some packet assemblies that are settings that we need to go ahead and set up so that when we import it into Civil 3D, our preview picture and our description and our name show up correctly. Then we'll go ahead and show you the Subassembly Composer toolbox, which is where all the tools sit. After that, we'll get into the Subassembly Composer flowchart, which is where we start to drag and drop into to create our subassembly. And then what we'll do is once we have the interface all covered and explained, we'll go ahead and build this pretty simple trapezoidal channel subassembly with width targets at the bottom. And so what this will ultimately be able to accomplish is some targeting where you don't have to have, 5, 10, maybe even sometimes 20 different subassemblies for the different width trapezoidal channels. You can just build one and add the targets to it. And then we will go ahead and open up a drawing and we will import our subassembly we're going to create and add it to a corridor. So let's get into the demonstration. What I'm going to do first is actually come into Civil 3D. So we will see this is a subdivision. And if I look along this edge, you can see there's a variable width channel here. This channel is pretty wide here. This is a slightly smaller channel. And as we get up towards the top, the channel is really small just because of the drainage area, and we're at the top of a hill. So in a typical workflow, I might have, 4 different subassemblies for this particular channel. One of the things that have always driven me crazy, I'm going to go ahead and show you. So I'm here in Texas. I'm not sure how it works in other places. This is where I've had most of my work experience. I'm going to go ahead and create an assembly. And let's just call this trap channel. Keep it simple. Go ahead and leave all these settings at their default. I'm going to go ahead and open up my tool space or my tool palette. And so out of the box, if you go to your trench pipes, Civil 3D does have what is supposed to be a channel. They also have side ditches. One of the things that I've just never been able to understand, I'll go ahead and select this one real quick. And we can actually leave all the defaults the way they are. When I bring this subassembly in, I guess I don't know if it's just a Texas thing, but I've never seen anybody have to profile the top of their channel. Everywhere I've ever worked, we've always profiled the flow line. And so right off the bat, yes, I can go ahead and select my assembly and toggle on and move this, where I need to where the flow line is then at my insertion point. But usually when I go to use these tools, it's not only that, if I come to the properties, a lot of these descriptions, they don't really make sense to me. One of the biggest ones where I just get driven crazy is this urban curb and gutter general. Now, if I come to the settings of this guy, these dimensions with just letters, they really are definitely not for somebody who is a beginner to not only design, but maybe even not a beginner to Civil 3D. But this doesn't tell you, unless you hover over it and wait for the help to pop up, what exactly it is. So, although, we would just maybe want this to say curb height instead of height of curb from gutter flow line to the top of curb. Um, Depth of the flange point to the gutter flow line. Um, you would probably have to pull up the help menu on this specific tool to see what exactly it's talking about. And so here's our flange point. And so that's where Subassembly Composer, in general, is a tool where we can definitely come in and get this out of the way. Come in and create not only our own subassemblies, but we can also have all those inputs be something that actually means something to us in general terms. So let's go ahead and pull up our subassembly composer. Um, this is a tool that everybody should have available to them. If you ever need to look for it, you just start typing in sub here at the bottom of your Windows search bar and it should come up. And so this is a pretty interesting interface to say the least. There's a lot of stuff just here when we kind of look at first glance. So let's go ahead and look at it from left to right. We have our toolbox, so these are going to be all of our tools. What we the workflow is you drag from the left into your flow chart, your different points, links, or shapes, or any of these advanced geometry. And so what happens is once you bring it into a flow chart, there's going to be a bunch of properties that are associated with whatever geometry you bring in, which will show up and be populated here on this bottom part. And also at the same time, there's going to be a preview right here on your right side, which is going to show you where exactly that geometry is when you drag it over. And here at the bottom, we will also have our additional parameters, our inputs and outputs, our packet setting, target parameters, which we will get into, super elevation if that's what you want to do, can't for rail projects, and then the event viewer. So these will be important for the actual settings that we want to show when we export it out to Civil 3D. So let's go ahead and touch on further on the toolbox. So at the top, we have just our basic geometry. If I want to create points, and what points are, if I actually go back to Civil 3D, this one doesn't, oh, it does have them. So there are these little magenta circles that show up. Those are all just points. And then there's a link, which is the line between the 2 points. And anytime I have a closed shape or closed points, so if I have 4 points, in a box, and I want to make that a shape, I can drag the shape into that closed point group, and it'll go ahead and create a shape for me. The advanced geometry. Now, this is where you can really get into some pretty pretty cool stuff. So the first is an intersection point. So if you had a point that you want to intersect, so let's say you have a top of curve, but you don't want to put a point, have to do some maybe some line work where you'd want to show a top of curve instead of a center line. You can actually have it calculate the intersection point of 2 points, and it'll go ahead and put a marker there for you. We can go ahead and do curves, links to surface, daylight rounding. There's a lot of stuff. One of the newer tools, so if we wanted to do an offset geometry, in this case where we're going to be building a trapezoidal channel, and it's going to be earthen, but let's say we wanted the bottom to be concrete, we can go ahead and offset our geometry for our bottom width, and go ahead and create a shape that would be a concrete for quantities later. And one of the cooler tools that has recently been added is loop geometry. So that this is where you can, let's say you have a stair step wall section that you're creating, and instead of having to create multiple pieces in here where it would be a step, a step, a step, you can actually put parameters in here that will tell it to loop as you drag out that specific subassembly. Auxiliary points here in the auxiliary section. Now these I personally like using. These are points that will not show up in the final product that we send out to Civil 3D, but they are here for markers. So um, I'll go ahead and let's say we wanted to do an auxiliary point where it's maybe a right-of-way line, but we don't want to actually show that point for export in our Civil 3D subassembly. We can go ahead and use auxiliary point. Maybe we want to have a horizontal line that you calculate off of. You can also use auxiliary links that won't show up. And there's also auxiliary links to surfaces, auxiliary intersections, and marking points. So the workflow. So right now we are showing our flow chart, and we can also go ahead and add in decisions. I'll go ahead and in a little bit show you an example of a decision. And so this is exactly what it sounds like if let's say you had a horizontal line that maybe represented a top of curve, but you don't want to have to calculate, let's say, a left and a right side of your street. You can go ahead and tell a decision to, hey, if I have a washout in my street and I decide that I want that washout once one side of my street drops or goes up a tenth of an inch, excuse me, to wash out the crown, you can have it make those types of decisions based on a true and false. Or if you want to switch the way the subassembly works, or what it's showing, you can use the switch workflow. Now, one of the things for calculating, let's say, distances, we can also set output parameters, or we can also define variables that can be used. Let's say for our channel, we want to build a left and a right side. We can define a variable that will be the bottom width, and we can apply that variable to the left and right side so that we don't have to have two inputs in our ultimate end user Civil 3D packet. We can also set variable value. set marker points, and then if you do get any errors, here's your report message. So now let's go ahead and start putting together what's going to be a simple trapezoidal channel. So first we're going to want to start with a point, right? You always have to start with the point. And the first point is always going to be your insertion point. So if I go back to Civil 3D, your first point will always be right here in the middle. It's going to be where it's going to tie into your assembly. Let's go ahead and drag a point over. And you see that it's created an arrow saying that from that circle, from our insertion point here on the right in the preview, there's our point one, our P1. And we can rename this. We can also add point codes. These are important if you want to ultimately be able to export these point codes as feature lines. And there is a whole section where you can go to the Autodesk website and find all the different point codes. If you want to use custom point codes, you can go ahead and do it. You just have to make sure that you're consistent. So let's go ahead and call this point code uh, up. And now there's different types of geometry that we can create with our point. So we can go from an angle to a delta x, an angle to a delta y, an angle and a distance, an x and a y, which we will use frequently, or we can go delta x to the surface. We can interpolate points. Slope and delta x are one that we will use for our trapezoidal channel. Slope and delta y, or we could just go a slope to our surface. Now, since we're going to be building the bottom of our trapezoidal channel, let's go ahead and leave that on delta x and y. Now we have to start from our origin point. And so let's go ahead and go, um, go ahead and leave it at 0 for now, 0 and 0. And here's some cleanup that I should have addressed earlier. So the first thing we want to give this is a name. So let's just call this trap channel variable with bottom. Now we could give a description. Sorry, no spaces allowed. And for the description is kind of like when we hovered over the out of the box Civil 3D subassemblies. This is where we can go ahead and put a description where somebody hovers over a subassembly, they'll know what it is. So variable with bottom trapezoidal channel. Now we can go ahead and add a help file. If we wanted to, we can also add an image. I didn't create one for this, um, but just like if I come back to Civil 3D, we can create any kind of PNG image. If you want to even take a screenshot once you're done and add it to your file, you can do that. And let's go ahead and add an input and output. So what these are is the input and output. If I go back to Civil 3D, I go ahead and select this. This is what the end user is going to see here. So for depth, there's 6 feet bottom width, 6 feet side slope. All these, if we were to dissect this in Subassembly Composer, are inputs and outputs. Now, the first thing that we would want to do is decide, are we going to make this all one big trap channel? Or would we want to be able to use this maybe on a right side and a left side? The reason that's important is if we were going to only build the right side, we would want to make sure that the direction is on the right or the left, whichever way you feel more comfortable building it. I'm going to go ahead and leave it at none because we're going to build it all as one big piece. So let's go ahead and create our first parameter. And we're going to call this parameter bottom width. And now when we tell it what type of input and output parameter is this, we can either just put a number, we could put an integer, string, we could do grade, slope, yes or no, what side. So for us, we'll go ahead and leave it a number. And let's say we want our bottom width to start off to be 10. And the display width or the display name will be how it's displayed in Civil 3D. So let's go ahead and tell them bottom width. And we could put a description. So when they hover over it, what's the description that you want the end user to see? Overall bottom width of track channel. So the reason we're putting this input and output in is we can now use this bottom width as an input for our X. Just make sure, so this is the X and Y that we're talking about. Just like we have in our CAD file, X is horizontal, Y is vertical. So if we want to use that bottom width, let's go ahead and we want the end user to put the overall bottom width. So what we would want to do is do the bottom width for our X. And if we zoom in, and we'll leave our Y alone. And I am getting an error here. Oh, and it's because I got a little bit ahead of myself. So there has to be a point at the origin. And so right now we do need to leave this at 0, 0. And let's go ahead and take point code off. And now we can do a second point by just dragging it over. And this point is where we're going to go ahead and tell it, let's go ahead and go from the origin, the bottom width. And you can see on the right side, as soon as I typed in bottom width, point 2 is now way over on the right side. But we don't want the whole bottom width on each side, right? We want the overall bottom width. So we want this to be divided by 2. So we can divide by 2. And you saw that it came in half of the distance. So now let's go ahead and add another point. And this one, we're going to want to go from the origin. And let's go ahead and do, just like we do with the Civil 3D left and right from the origin, we were going to want to go a negative bottom width divided by 2. And so now with the end user, no matter what they put here for a bottom width, it's going to divide by 2 and it's going to set those 2 points for me. And we're going to want this to be part of our top surface. And we're going to want this to be part of our top surface. Go ahead and make sure you put the parentheses in there. And so the next input that we're going to want to create is our side slope. Right, we're going to want the end user to be able to put in a side slope. That way we can calculate our our uh, our sides of our trap channel. So we can just call this side slope here, and this is going to be a slope input. And let's go ahead and do a 3-to-1. And what do we want the end user to see? We want them to see side slope, and the description when they hover over it, side slope of trap channel. And so now with this parameter created, let's go ahead and add another point. And this one, we're going to go ahead and go from point 3, which is there. But what we're going to want to do is go ahead and, instead of just doing a delta X and Y, what we're going to want to do is do a slope and a delta X. So we're going to want it to go 3-to-1, let's say for 6 feet to give me a 2-foot depth channel. So let's go ahead and do slope and delta X. And for our side slope, or for our slope, we can just go ahead and enter in our parameter that we put over here. So I'm going to type in side slope. You can see it went way up there. So let's do a minus side slope. So that was correct. And so for our width, we need to go ahead and create a new parameter, right? And this width is going to be, um, whatever the width is that we want it to go on our side slope. So we could do side slope width, which is just, this is the computer side. We're going to want it to be a number. Let's go with 6 to make this thing 2 feet deep. And our end user, we're going to tell them what's our side slope offset. Side slope offset be the description that they will see when they hover over it. And so now what we want to do is have this go to the left. We want it to be our side slope width, and there will be our 3-to-1. And we don't want to add any targets to any of this. So everything's good. Let's go ahead and make sure that this is also part of our top surface. And now let's go ahead and add in another point, our final point. And so what we want to go is actually from point 2. So here we just have to do the drop down. Our starting point is from point 2. You can see that it actually put it right there over it. And we're going to go slope and delta X. So we will do our side slope for our slope. And we will do our side slope width. And we don't want any targets there. And we want this to be part of our top surface. And so now let's go ahead and go back to point 2. Let's go ahead and tell it to add a link, but it doesn't want to because we're going from our origin. So what we could actually do, let's go ahead and drag a link over. And we could tell this link we want it to be part of our top surface. Now let's go from P2 to P3. And there's our bottom width. And so at this point, we could go ahead and save it. And let's go ahead and do Call this one trap channel. Go ahead and save it. And now let's go ahead and minimize Subassembly Composer. Let's go ahead and bring it into our drawing. So let's go ahead and delete this one out. And let's go ahead and import the subassembly. Actually, before we do that, we need to add our targets, right? To make sure that this guy can be a variable with our targets. So let's go ahead and go to our target parameter. And we haven't put anything in here yet, right? Let's go ahead and do a target parameter. First one is going to be a left width. So L width. Now we're going to do an offset target. And let's go ahead and do -5 for, and so the display name, so this is what they're going to see um, when they're in the corridor properties and they go to their targets. This is what the end user is going to see. So let's call this left bottom width target. And so you can see here's a preview of our width. If we actually go to our point 3, you can see there's no way for us to actually add the offset like we did before. So what we're going to want to do, let's go ahead and copy this code. Let's go ahead and do a slope and a delta x. And the reason I did that is because I want you to be able to see the only way to get these targets where these override targets are when you have a slope. And I wanted to be able to point that out to you. So the bottom of our channel is going to be a 0 slope. And let's go ahead and paste in the code for half bottom width. And so now, because we have a target created, we can tell that there's an offset target where when it's selected, you can overwrite the width and go ahead and use that target. And so here's, if we look up here at the preview, we have a -5 in there right now. We'll go -6. So now we can see it's working. Or if we go -4. And so this is just a preview, so we'll leave it at -5. But let's also go ahead and create our right side target. So we'll go right width. Again, create an offset. This one will be a +5 since it's on the right side. We'll do bottom width. And there we go, it's up here. And now let's go to our point 4. Oh, point 2 actually. We'll do the same thing. Instead of just X and Y, we're gonna have to do a slope and an X. We're gonna go from the origin, 0%, and we're gonna go bottom width divided by 2. Now let's go ahead and save this. And let's go ahead and come back to Civil 3D. And now let's import it because it's ready. So let's go ahead and go to our properties in our tool palette. And we're going to go to the import subassemblies and our source file. Let's go ahead and go to my folder where I just saved it. There's my trap channel. And it's a PKT file. So let's go ahead and open it. Now, where do we want to add this? Let's go ahead and add it to trench pipes. So that's where the other ones are. I'm gonna go ahead and hit OK. And should be in here. So let's go make sure there's not another trench pipe. Or let's just create a new one. So customize our palettes, and let's just create a new palette. And go ahead and throw it. It's already in there. My Imperial Subassemblies, Superb Web, and let's add it back in. Work Web, and there it is. So now, because there was no picture, it's just going to be a square, but we can still select it. And we come to our properties, like we were showing before, our bottom width is going to be 10, slice slope is 3:1, and we have an offset of 6. So it'd be a 2-foot deep channel. If we wanted this thing to be 3 feet deep, we could go with 9 there. And now we can just go ahead and select our assembly. There's our entire assembly ready to go. So now real quick, let's go ahead and see this in action. So I'm gonna go ahead and create a corridor. I know it's gonna be drain D, and that's gonna be my profile. Let's go ahead and start with the trap channel. Go ahead and leave that the same. Let's go ahead and start from back here, and we'll add a section all the way through. So the reason I picked this, let's go ahead and change the frequency. That's a little bit too spread out. Apply. Let's go ahead and rebuild the corridor and hit OK. We can see there's our subassembly. Well, it might be too small for this section, but not only is it too small, but this bottom part is going to want to transition down to the pipes. So I already have some polylines in here. You could also use feature lines, but let's go ahead and edit the targets. So I'm going to go ahead and select this. What's our left target going to be? Let's go ahead and select these two polylines. And on the right side, let's go ahead and select those two polylines and hit OK. And this did this left side. So let's go back to our subassembly. So we see that even though we created it, well, we never actually assigned it. So let's go ahead and assign the right width. Let's go ahead and save it. And so one of the things we can do is we can just overwrite this subassembly that's already in here. So I'm going to go to import subassemblies. Let's go ahead and import back into our current web. It's going to say you need to restart Civil 3D, but it doesn't. So we can actually just have a second one in here. So now let's go to our actual assembly, erase that old one out, this new one in. Let's go ahead and rebuild our corridor. Let's reassign these targets. The left side and for the right side. There we go. And the reason I did that is so that you could see. So you can go ahead and create or import the subassembly. And even if you have to make changes to it once it's in a drawing, you can go ahead and overwrite the subassembly that you already created into a new drawing or the existing drawing. And so now if we were to go ahead and say, well, this thing's actually supposed to be 12 feet, so 4-foot deep channel. If I go ahead and close this out, I can just come into my subassembly, go ahead and make this 12 feet wide. Now when I rebuild my corridor, there's my channel. And you can see that it's actually tapering down. in that area for me. And what we could also do, if we had more time, is go ahead and come in and actually create another target for our width for our P4 and P5 and have it hit this elevation out here, whatever the elevation would be. And so just to show how versatile this is, let's go ahead and see how wide this one is. This channel up here. So it's only 5 feet wide. So since this is using targets, I can actually come over here and tell this one, I only want you 5 feet wide. And even if I rebuild this corridor, it's using targets, so it's not going to overwrite that. But what we can do is add in another region. And it can be this region all the way, let's say through there. It's going to be my trap channel assembly. We don't have to set any width targets for the bottom. And there we go. There's our bottom width, 5 feet deep or 5 feet wide. And again, if we had targets set up for the top of the trap channel, we can also do that. So if there was an area where you were transitioning, let's say from a wider trapezoidal channel to a narrower trapezoidal channel, you can again do that with the targets. And that's where this tool, once I got in there and started doing a lot of these simpler subassemblies, I got really creative, and I'll go ahead and show you maybe more of the more complicated stuff, but it's definitely something that we can um, come in and start doing. And so I'm going to go ahead and open. This is a custom subassembly I created, and you can see I'm using auxiliary points here and an auxiliary line to go ahead and calculate my L4 and my L5. And here's the one I was telling you about. So I have these auxiliary points that I'm going to use for calculations. But while it's doing that, then I wanted to make a decision whether I want a washed out crowned or a regular crown street. And so if I come to my decision, I'm telling it, hey, my top of curb, right elevation minus my top of curb elevation. If it's less than a tenth and if it's over a tenth, then I want you to either wash it out or leave it crowned, whichever is false or true based on that decision. So if I actually come to my target parameters and you look, here's my top of curve right, my top of curve left. If I go ahead and adjust this right side to, let's say, zero point 0.5, you can see that because of this now being over the 0.1, it made my decision. And now what it's doing is straight grading from P3 through to P1, and it has washed out my crown for me. And just to see it in action again, if I make this 0.09, my crown is back. You can see on the right side, the crown is now back because there isn't enough vertical change on this right side to trigger my decision. But if I make this 0.1, now it has triggered the decision. And now my crown is washed out on my street. And this is where you could start getting into lot grading. Here I have a subassembly that's my entire street section. And instead of having to do a completely separate subassembly for um, for quantities, I've had these subassemblies before with the out of the box where I put a lane, let's say as a basic curb, and then a link width and target my for my right my parkway. Then what ends up happening is when I try to run this datum surface down here, because these are different parts, sometimes it'll spike right here or it'll spike in different areas. So by actually building this as one whole piece, I'm able to not only control the top surface, but I'm also control how the datum surface for quantities is controlled. And with this one, I'm also able to have variable with targets. for my streets if I'm widening or shrinking the street. Um, so this is where, again, you can get very complicated like this, even though it looks like it's simple. If I start coming into the street section, here's all the work that is being used to create this subassembly. And hopefully, what I really wanted to accomplish with this webinar is to not only show you guys how this tool works, where if you want to do real simple things like this, but also if you want to get really complex, if you have walls that you want to create, um, stuff that the out of the box tools just won't help you with without creating this monstrous tool. And not only that, when you start looking at the targets with some of the variable width, if we go into the basic lanes or the subassemblies. So if I was to create, a bunch of targets or this basic lane transition, and I start going into the actual corridor and looking at, I need to know, I need to not only label this correctly, but then I have a bunch of targets that I need to figure out what is targeting what. So it could get very complicated where I could just now come in, build my own street section. And you can see, so my input and output, this is all that the end user has to put in is curb width, curb height, uh, curb offset from the center line, and what their subgrade is. On the target side, all they're going to see is 4 targets. They're going to see 2 targets for your elevation target and 2 targets for your offset target. Where if I was to build this out of the box, I would have had a bunch of other targets for those basic lane transitions, and it gets really confusing if you don't name them correctly. So with this, I've just found it just a lot easier, especially for CAD managers, to have tools where you're helping the end user not have to sift through, all these dimension A. Um, if I go back to this generic curb, I honestly, I would be terrified if I told a fairly new or novice Civil 3D user to come in and create my curb for me, knowing that they have to understand what all these dimensions mean based on these descriptions when they hover out. So it's a very efficient tool. I really hope that this really starts to open your mind up to possibilities. And again, if you guys have any questions, please feel free to ask them in the Q&A section of the Zoom interface, or if you want to reach out to me directly, you can reach me at fcortez@atgusa.com. And again, I really appreciate you guys taking the time. I love being able to teach you guys these types of tools, and I hope you guys have a good rest of your day.